Hello, everyone, and welcome to today's webinar, Smart Buildings, Enabling Facility Control and Automation. I'm Jennifer Getz, the Editorial Director of Facility Executive Magazine, and this webinar is presented by GridPoint. Before we get started, I'll cover a few housekeeping items. Our speakers are on video today, and if you would like to view them at the top of your screen, look for the bar in your window to pull down so they are visible to you. Next, please note the control panel on your screen. This is where you can submit questions via the question box at any time. There will be a Q&A portion after this presentation, so please type your questions in there to send them to us. If at any time you experience a technical difficulty, please send us a message via that question section and someone on our team will answer you privately. Also, please note the orange arrow on the left side of your control panel. Clicking on that arrow will either expand or collapse the control panel, so please be sure the panel is expanded so you can access the question box. And if you are interested in continuing education credits, please note that you receive a certificate of attendance in an email from Facility Executive after this webinar. You can report to your association for the credit. Now I'm pleased to be introducing your speakers for today. John Cannon is a solutions engineer at GridPoint with a strong background in industrial control systems and automation technologies. He began his career as a project engineer where he focused on designing, programming, and commissioning industrial control systems. Throughout his career, he transitioned to working with major automation suppliers, providing consultation to other engineers on creating solutions using automation technologies. Jamie Rotbert is the Manager of Sales Enablement at GridPoint, a leader in building energy management and optimization technology that decarbonizes commercial buildings and drives grid modernization. He brings over 6 years of experience developing clean tech solutions to GridPoint, where he works across various departments, including partnerships, product, and sales. John and Jamie, thank you for joining us today.
Thank you so much. Well,
Thank you.
Thank you for the intros. We're both really excited to be here. I've attended many of these webinars, and it's often just a couple people talking to some slides, and the hour goes by, and you maybe zone out after the first 15 minutes. So we're going to try to keep it really interesting. There will be polls throughout, which hopefully are engaging and enlightening to everyone, including us. We'll try to keep it casual, keep it conversational, and let's jump in. Let's talk about smart buildings. All right, 1 second. There we go. So you just met us. We can move on from here. Let's talk about the agenda for today. So really, I think before we jump into this, the main takeaway for today is that the term smart building can mean a lot of different things. And I think what we want you guys to leave here with is that a lot of very simple changes and simple technology can make a massive difference to how you manage your facilities, how you're managing your energy spend, and your carbon footprint as well. And so a lot of the things we're going to talk about, they're not rocket science. They're basic things, and many of the solutions we'll discuss are very low cost as well. So we'll kick off today talking about common challenges of buildings that are traditionally managed. We'll talk about the different components of a building management system, which is really the heart and the brains of a smart building. It is the technology that enables you to have a smart building. We're going to talk about using smart building systems to enable better control over your facilities. We're also going to talk about automated control, so that'll be interesting. We're going to talk about improving energy efficiency and sustainability goals with smart buildings. It's kind of a really awesome side effect of a lot of the waste reduction that building management systems can bring. We're talking about reducing maintenance costs, and we'll go through some results at the end, which should be interesting. So with that, let's jump into what defines a smart building. John, take it away.
Yeah, so when we break down to what are the basic components of a smart building, we start out with like an IoT sensor or device. That's just a device that is gathering a piece of data like, hey, what's the temperature? Is a door open or closed? It could be a switch. And once it's taken that information, it's able to transfer it like through a network over to like a building management system up there on the right. That's typically like a controller that's on site, and its job is to implement a control strategy. So it's taking data from the various sensors and coming up with the strategy for control, and then it's sending that a command signal, as an example, out to an actual asset on the bottom right there, like a HVAC unit. And so if you're, as an example, if your IoT sensor is registering temperature in a dining room, and let's say it says it's 74 degrees and you have a set point of 72, that information, as an example, would be transferred to the building automation system. It could implement control strategies to send it down to the HVAC unit. The HVAC unit would come on, start cooling down that area, and then you have a closed loop. So now it continues on. So the sensor continues to monitor that change that the unit has started, and able to basically maintain temperature through that closed loop. It's a constant feedback, and it's making adjustment. The building management system on site, that controller, it's collecting a lot of data there locally about what's going on with that building. And one of the nice things with a smart building is we're not just keeping that information there locally. We're able to take that data and securely connect it to remote access through, as an example, a database that's collecting information about it, allowing it to be analyzed, allowing things to be done. So I like to think of it that, without a smart building or this kind of technology, a building could almost be like a black box. I mean, really, you might be down to somebody picking up the phone, if you're a maintenance, and them calling you to tell you about what's going on with the system. You don't have the ability to get in there and see what's going on. And now with this type of system, you can.
Awesome. So yeah, I think John did a great job touching on this. A key part of your building management system is the sensors you put on site. Those are your eyes and ears. And later in this presentation, we're going to talk later about how building management systems can be a massive cost and time reduction in truck rolls, sending people out to a site to show up on site, walk around the site, disrupt the flow of the site, disrupt potentially customers and employees. Sensors are a way of detecting what's going on at a facility and showing that data remotely, so you don't need to send a truck out to go detect what's going wrong, right? So these are 4 sensors we'll talk about today, and we'll talk about some others, but you can imagine that really any sensor that you want at a facility can roll up into that controller that John was talking about and broadcast that information to you remotely, which can be very valuable. So temperature sensors, primarily we're talking a thermostat. These can measure the temperature in different areas of a building. They can also measure the temperature of walk-in fridges, reach-in coolers, etc. And really, when we talk about temperature, we're talking about employee comfort and customer comfort. And we're talking about moving away from thermostats that maybe they have a schedule you can program into them, but it's not a schedule you can control remotely from software. It's not maybe a schedule that you can roll out to many different facilities across your enterprise, all with the click of a button, right? So more advanced temperature sensing would enable something like that. The second one is energy. Many of you are interacting with energy data through your utility bill management provider, or they're literally sending you PDFs of your energy bill, or maybe you can log into your utility and see your energy consumption, but that's going to be monthly data. Typically, it's going to be a monthly sum of your energy consumption for that month. And with main load metering, which is when we actually monitor the total consumption of the building, you can actually see down to the second, down to the minute, down to the hour, how your building is consuming energy. And that really that can become a lot more valuable when you're trying to implement controls to lower your energy costs. So for example, if you're finding that a lot of your energy consumption is during peak hours of the day, you can implement processes and automated controls to shift your consumption to a lower cost period of the day. Many of you may not be on a time of use rate where that's eligible, but if you do have a demand charge, which we'll get into later, measuring those energy peaks and trying to implement better systems to avoid high peak charges, that's where the energy monitoring comes into play there. And we'll get into a lot of that later. Finally, air quality and CO2 and light. These are pretty standard. One thing I'll say about CO2 is with a CO2 sensor, you can actually measure how occupied a particular room is, right? When a lot of humans are in a room, everybody's breathing out and the CO2 will rise. And so we saw during COVID particularly that a lot of clients were leveraging CO2 sensors to not only instill best practices to keep rooms at a healthy occupancy, but also set up automated controls to flush air out and bring in new air based on a CO2 measurement they were taking. And yeah, light sensors, pretty standard, just controlling lighting systems based on ambient lighting you're measuring in a space, based on sunrise and sunset, maybe for exterior lighting. We're gonna get into all that, but these are kind of some standard sensors here.
Would you go back one slide? I did forget to mention one thing that you brought to mind looking at this. You know, I did the, and perhaps everybody here is tested with it. I did a chat GPT test and said, you know, what does it say about, a smart building? And it wasn't too bad, but what it kind of missed or what it gave me the impression of is a smart building is only for new construction or new build outs. And the reality is it's not. I mean, companies like GridPoint, we specialize in retrofitting normal buildings and given this capability to them for low cost. And what maybe even think about it was in Jamie's site there, lighting. You may have a site where there's, existing, maybe you've just got a simple timer or lighting contactors. We can take over control of those and bring that information in. So there's just a lot of things that can be done. And if you have an existing portfolio of buildings, I mean, this is definitely a possibility to add to them.
Absolutely. And the whole script I'm reading today, word for word, was made by ChatGPT. So you just blew my cover. So there we go. I am an AI. Anyways, all right, we're here for our first poll. So should I leave it on this screen?
Perfect.
While we do the poll? Oh, there we go.
Yes.
Awesome.
So how are you being alerted to building problems? Select one of the following: calls from store managers, submitted maintenance ticket, automated ticket from EMS/BMS, or customer complaints or other. You have about 30 seconds to respond.
I think we're able to watch these answers flow in as you guys submit, which would be really fun.
Okay, the results are in. It looks like a submitted maintenance ticket was the highest at 52%. And then the second was customer complaints, but at 15%. And following that was calls from store manager and automated ticket from EMS/BMS at 12%, and then other was 9%.
Yeah, that's a pretty broad range. The thing that I was thinking about this, and I'm going to address later on, is, there are human factors involved with being alerted for building problems. From most of these, somebody's decided to do something about what they perceive as a problem, and then it gets logged in this way. So I'm going to talk a little bit about later on. That's interesting statistic to see, though.
Yeah, it's interesting because maybe many of you in the audience have a system for managing tickets as far as being alerted to problems. But a lot of what we're going to talk about today is what's that next step? How are you seeing into the building to diagnose what's been reported as a problem? Someone raised their hand and says, I'm uncomfortable in here. The HVAC's obviously broken. Do something about it. It's really that next step of what technology are you leveraging in that next step to be able to see into that building without necessarily needing to send a truck out to go get a better understanding of what's going on. Okay, I'll go back to full screen here. All right. Okay.
I think we can go back to the presentation.
Yeah, can you see it on your end, John? You know if that transition worked? We'll
No,
get
I
better
still
at
see
this.
the quick poll.
Uh-oh.
I see the presentation.
Okay.
Oh, we're back to the presentation. Yeah,
Maybe
slide
it's
one.
lagging on your end. All right, I'll keep rolling, but if others are not seeing the slides, we'll stop and fix it. All right, so now we're going to get into challenges of traditionally managed buildings. So this is what we typically hear when we come to an enterprise or a business that is managing many different facilities, right? So the first one, and hopefully this resonates with some of you. My tenants and customers are constantly uncomfortable. They're battling over set points on the thermostats. I've got one, we've seen one thermostat on one side of the room set to cooling, and then the other one on the other side set to heating, and they're just battling each other, right? I put plastic boxes over my thermostats with a lock and key, and I have my employees are stealing the key and unlocking it and changing the set points. I mean, we see these nightmare scenarios all the time. My thermostat schedules are all over the place. I have no idea at a particular facility what the thermostats there are set to. I have no view into that. Maybe we did an audit last year and we went in and we put in intelligent schedules and we said, okay, from 8 a.m. open to 5 p.m. close, we're going to be set at 71 degrees, but what new managers come in and you have what we call operational drift. You guys are all familiar with this, right? Over time, things drift and entropy sets in, and you no longer have central control over what your thermostats are set to. The third one here, my employees forgot to turn the lights off. Right, that could be lights, or that could be something a lot more critical. We've seen customers that have assets like a burrito press, for example, where they're leaving that on overnight and it causes a fire. If you have standard operating procedures for your employees to be doing things for safety, I mean, lights are safety as well, right? For outside parking lots, signage as well. If you have processes in place that you're relying on employees to not forget to do that, that's often not optimal, right? Because we're human and we forget to do things. Food is wasted because my cooling units aren't working properly. Self-explanatory. I don't know what assets are aging or need repair. So this is a big one, right? You may, we're going to talk about kind of proactive maintenance a little bit later, but understanding and being able to prioritize which of my HVAC units, for example, are performing the worst. Like I've got a bucket of money and I've got all these HVAC units. How do I allocate this to replace ones that are aging or old? And it can be very difficult to understand how to prioritize that, especially when you're managing 10, 100, 1,000 facilities all at once. Finally, I don't understand how my building is using energy. I see these energy bills come in, and maybe I've instilled some best practices to reduce that energy consumption, but how am I tracking towards those goals? How am I closing the loop, right? I've set goals on reducing energy, whether it's for climate reasons or just for cost reasons. How can I close the loop and make sure that what I'm doing is actually working towards that goal? So these are several of kind of common quotes we see when we go out there in the field.
And as somebody that I've visited many sites doing customer surveys, all of the time you see thermostats that are set wrong, permanent hold, two different set points, one heating, one cooling, fighting against each other. I mean, all of those things represent, energy that is being wasted.
Yeah, it is amazing how simple a change it is to start instilling, smart remotely managed thermostats, and how much of a difference it can make. We'll see at the end a case study, but yes, having thermostats be centrally managed with, we'll talk about like override boundaries and things like that, but yeah, thermostats are something we always see as a major problem. All right, so let's get deeper into the components now. And John, I have your specific order here. I turned it into a song, so I know which way we're going to go.
Yeah. So once, what would you expect, I guess, from a building management? What would you expect it to help you achieve? You know, one of them is like air quality. So being able to monitor air, CO2, humidity. You'd like to be able to understand what's going on at that building and be able to control those factors so you can, you know, ensure comfort and quality to the occupants in that building. Okay. Lighting control. Wouldn't it be nice to be able to schedule and control your indoor, your outdoor, your signage, you know, across multiple locations if you have them through a single platform? I mean, that'd be very powerful. Go ahead. How about HVAC unit performance and tracking? You'd like to be able to control the units in a way that they're efficient, you know, they're saving money, they're maintaining comfort, and you'd like to be able to get information from them that would help you, you know, prioritize, you know, maintenance, troubleshooting, or repairs. How about being able to track temperature or like door switches as an example for coolers and freezers? If a freezer is not reaching, has lost its temperature, it's heated up. Was that the cause because somebody left the door open? Could it be that the door was closed, so potentially there was a failure with that unit? So, and then finally, you know, taking all of those things together, you can better, you know, maintain and manage the asset. You know, you're able to keep a schedule, you know, figure out perhaps when to do repairs, and do them in a manner that's going to be, you know, the most cost effective instead of, you know, only when things break. Because as an example, you know, if you can identify early enough with an alarm that a door is being left open in a freezer or a freezer is slowly losing temperature, you can do something about that and potentially save a waste of a product. Next. And then implementing smart thermostats. So, you know, not only just ability to control them and schedule them, which is a big deal, that's a huge energy saver, but there's also additional things that can be done to help them save energy. Algorithms that help them during transition periods to optimize coming up to temperature and basically coming back down. You know, and then also getting information about what is happening with units and then being able to report that. So it's all part of a big system.
Yeah, and so when we talk about the benefits of a building management system, I think, you know, we've kind of been slowly getting to this point. So I'll try not to repeat myself too much, but yeah, I think this view on the right is really interesting. Like, virtually walk through a building with us, right? We're going to have, as we walk into this dining area, you know, we're going to have a central controller mounted on the wall. Any assets in that building or in that zone can be tied into you know, some kind of smart integration where they can be controlled by that central controller. You know, for example, I have Hue lighting in my house. You know, I can control my lights from my phone. That's a very simple example of kind of a central hub talking to other assets. In that case, it's a light bulb, but it can be other smart appliances. Or in the case of GridPoint, actually, it can be simple on-off control, where we can turn you know, entire circuits of a building on and off from the control of a mobile app, right? Lighting controls, very similar to asset control. We're obviously talking about lighting and signage there. HVAC controls are, you know, your thermostats, refrigerator door monitoring. So again, not only the temperature of that fridge, but the door position. And then key to this is weather data. And it is critical to have all this information about how your facility is using energy lined up to weather, because climate control is such a driver of energy usage and waste. It's a major percentage of your energy waste. And you know, you may see on a given year that the energy waste is a lot higher or even lower. And you need to be normalizing that to the outdoor weather, not only the temperature, but also humidity, because even things as far as, you know, how sunny it is outside will drastically change how hard your building needs to work to keep that space to keep that space controlled. So this is all about streamlining facility management. We're improving energy efficiency. We're making your buildings perform optimally and on a schedule. We're eliminating inventory waste such as food. Obviously, with that comes reduced carbon emissions and limiting strain on the power grid. John, I think this is a good time to introduce and talk a little bit more about the strain on the power grid. What do you think, or do we get to that later?
Yeah, sure. I mean, I think that would be fine.
Okay.
Yeah.
Okay. Yeah, because I think that last one is interesting. There's really two aspects to how a building management system can help. So first of all, why should you care about limiting strain on the power grid? That's kind of the first thing, right? It obviously comes back to money. All of our desires do in the end, right? I'm kidding. But there's two components to this. One is limiting demand charge. So many of you have probably seen your utility bill and you're seeing a charge that's not related to how much energy you consume. It's a charge related to how much power at a given 15-minute interval you are consuming. Sometimes it's a different interval, but traditionally it's 15 minutes. And what that means is like the peakiness of your building. So let's like, if we were to draw a graph of how much energy you're using over time, right? Buildings that are flat and not having large surges and peaks are going to have lower demand charges than a building that has these inrushes of power and these large peaks. The grid doesn't like when we do that because it makes their life harder to have to turn on more power generation assets to feed that ever-changing load. So the grid, the utility, is really instilling two things to help lower those peaks. One of those is putting demand charges on your tariff, which we all hate because it can be up to 50% of our energy bill every month. It's a very, very high cost in some territories across the country. The second one is they give us an opportunity, which is called demand response, where we can actually, during critical periods of the day, we can lower our energy usage and be rewarded for doing that. You guys have probably seen like Nest rush hour rewards or things like that. All of your commercial facilities, there are programs across the entire country where you can be participating with the grid and being rewarded for lowering your energy consumption during peak periods of the day. That's called demand response. And you want to be looking for thermostats that have demand response enabled. I know this is not maybe a new concept to many of you, but it is an important note that a lot of this is automated today. It's no longer pick up the phone and calling a facility and asking them to ramp down their power. It's all automated, hands off. You set it and forget it, and your buildings can really add up to a very large, what we call like a virtual power plant to assist the grid with managing peaks.
Yeah, and we do things that help make that perhaps more palatable for a facility that you might not have considered before. So you're kind of like, hey, demand participating in that program sounds nice, but boy, I don't want to do that at the loss of comfort in my facility. Well, part of an automated system is we implement strategies like, once the time has been set when they need us to cut back, we would actually like pre-cool the building to allow us to help ride through so that you're not giving up the comfort at the facility and yet you're still able to participate in the programs. So there's things we do with the technology to help mitigate that and make it a good and viable program.
Absolutely. Yeah. And even that is something with a lot of these modern systems you can configure. You can configure how much you want to pre-cool and balance performance during those events versus disruption to comfort. A lot of those are kind of parameterized, and you can in a modern intelligent platform, you'd be able to kind of configure those parameters. All right, enabling streamlined facility control with a smart building system. John, did you want me to take this one?
Yeah, no, I was going to talk about this. Feel free to jump in. So one of the things you can do with an automation system like this is get real-time data and analytics. So you have the ability to go in and actually see how your building is operating. You can go in and look at individual HVAC units, see how they're performing. You know, if one of them has been brought to your attention that there's an issue with it, you could actually pull it up and check the temperature right away. So it allows for better decision makings, you know, when you're trying to detect or escalate problems. Another thing that I think about is, you know, this real-time data that's coming in about what's going on at your building, that information is being logged, and it's being logged historically, and that information can be used as some of the analytics. Some of the analytics might be, you know, hey, I see a potential, you know, issue with this unit. How was it operating last month? How was it operating 2 months ago? How was it operating 3 years, a year ago? You know, can I see a trend where it's gradually, progressively getting worse? You know, looks like we're heading towards a potential failure. So being able to capture that, all of that information and store it historically can be valuable. Another thing is the remote access and control. So, you know, once again, you know, by leveraging IoT technologies and cloud technologies, which we've all heard about, that kind of stuff, that technology allows us to actually take what's going on at a facility or a group of facilities and give you that information in the palm of your hand. I mean, you don't have to boot up a computer, you don't have to dial up on some proprietary network. You can actually have that information available to you when it's most convenient, almost pretty much in your pocket from your phone, if not a larger device. And once again, having the information quickly available to be able to make decisions, you know, once again, it's a big advantage. I mean, the same information could even be used by the technicians as they're doing a repair. You know, hey, I've actually believe I've completed the repair. I want to trigger the unit and see how it responds. I'm not even going to have to walk downstairs and type in on a thermostat. I can do it from up here on the roof while I'm working on it. So there's just a lot of capabilities that this technology is going to bring that you'll be able to access. You know, the smart algorithms, you know, enabling those. We've kind of talked about those some. You know, being able to, you know, uncover waste. You know, try to identify those and take care of that. And then also the automation of like tasks, you know, once again, you know, scheduling of lighting, you know, adjusting, you know, HVAC set points automatically, you know, when it's occupied versus when it's not occupied. And then, you know, allowing the scheduling and of maintenance on various equipment, you know, so these things can help reduce, you know, the workload of a facility management team that's, you know, often those teams are very busy and there's a lot to do. So tools that can help with that function, I think, are gratefully useful.
Absolutely. So let's dive into some of these smart algorithms. Actually, right now we're not just talking. I think if we take a step back and we talk about what have we been talking about up to this point, a lot of this stuff has been probably things you were aware of. You know, you've been thinking about. And maybe it was nice to see it all kind of laid out as far as, you know, walking through a whole building and seeing areas where you need sensors and you need, you know, remote access to that data and things like that. Now we're going to go a level deeper into actually some benefits of a smart thermostat, which is the example we're going to talk about. But you can imagine that as you get more, you know, these analogies can expand beyond thermostat, right? There are smart fridges, smart water heaters, things like that you should be thinking about. But for this presentation, we're going to talk today about some smart algorithms that can exist on, you know, smart thermostats. And while you're shopping around for them, you should be looking for these because they can be very beneficial. All right, so the first algorithm on the left is called load curtailment. And so that algorithm is actually designed to reduce demand charge at your facility. And so what it does is it actually is going to limit energy use of assets that it has under control, in this case HVAC units, when it detects that your building is approaching a new peak. Okay, so let's do an analogy. Okay, let's say you have a restaurant and you have a bunch of EV chargers outside. You probably don't have those yet, but you'll probably have them soon. And you know, everybody shows up at 3 p.m. for their burrito, and they want their mid-afternoon burrito, and they want to charge their vehicles while they come in. So at that time of the day, because that's kind of this like cyclic usage period, your building's going to be having this inrush of power as everybody plugs in their vehicles. Maybe employees arrived an hour earlier, and the space is trying to cool itself off from the unoccupied setting, right? So a lot of things are going on at once. The HVAC units are ramping up. Everybody's plugging in their cars. Your burrito presses are firing up, right? So your building's using a lot of energy at that moment. An algorithm can kind of see that that's coming and learn those patterns over time. And what it can do is change the way your HVAC system behaves to minimize that inrush. So rather than ramping up all your HVAC units at the same time that your EV chargers are all being plugged in, it can dial back on. It can relax the set points of your HVAC system when that inrush comes, so that the peak load during those 15-minute intervals I was talking about can be minimized. So that's really a play to reduce the peakiness of your, right? When I talk about peakiness, it's that chart I was drawing, right? Like how much is your building's energy going up and down and these inrushes of power? Algorithms like this can kind of flatten that out. And they leverage modern technology, which machine learning, not quite ChatGPT yet. They'll probably get there soon, John, so don't worry about it. But machine learning to identify these patterns. And what's so interesting about them is it's not just showing you the pattern and saying, go figure it out. These modern systems are controlling your assets automatically, so you don't have to think about it. You can enter some parameters, right? Some boundaries, and let the algorithm go and watch your demand charge be reduced month over month. That's the goal with these types of algorithms. The last two are fairly straightforward, but they are important to talk about. HVAC recovery is how you transition from unoccupied to occupied. So for many of you, that is when your facility opens. Let's say your retail, that's like the employees arrive 15 minutes before, and then all your customers arrive. Or if you're a restaurant, maybe your employees are arriving at 6 a.m. and you're opening for breakfast at 8 a.m. That transition from unoccupied overnight to opening in the morning, that's called HVAC recovery. And similarly, HVAC setback is how it transitions to unoccupied at night once you're closing up shop. Why is this important? So there's kind of the traditional way that an HVAC would kind of ramp up in the morning to start cooling your space, which is to say, okay, I know that I need to be set at a certain temperature based on how the schedule is programmed at 8 a.m. when the facility opens. And so what it will do is at 8 a.m. it'll start trying to achieve that set point. And what may happen, depending on the age of your system, is that it's now 8:30 and you just hit that set point. Right? The system has been cooling, and what's happening is from 8 a.m. to 8:30, you're not really at the set point you want to be, and people are uncomfortable inside. Some other systems may actually have some level of predictiveness to say, I know that I'm opening at 8 a.m., so I'm going to start cooling at 7:30. But then it only takes 10 minutes to cool that space. So by 7:40, I'm right at the temperature I want, but now I'm just sitting here for 20 minutes cooling even though no one's here. So I hope that kind of shows you kind of the fallbacks of both those sides, where you're either too early in the beginning of the day at cooling, or you're too late. What you want, again, is something algorithmically driven that is learning how your building transitions. Every day, you want to, a system like GridPoints kind of monitors how long it takes for your building to drift, to change from, I put it to 80 degrees overnight because no one's in there, and then I got to cool down to 72 degrees by 8 a.m. How long that takes, that drop in temperature, it'll learn that over time, and it'll kick on the units so that right at 8 a.m. you've hit your new, you've achieved the set point you wanted. So you're not late and you're not early. I probably could have said that in half the words, but hopefully that makes sense to you all.
Yeah, I don't know how we're doing on time.
Mhm.
Running
Perfect.
close.
Yeah, we can pick it up, John.
Okay, so we've come to another poll question. What smart technology does your building currently use? Check all that apply. You have, again, about like 20 to 30 seconds to respond. All right, the results are in. So the majority, 67%, said building management system. Close second, smart thermostats at 58%, followed by smart sensors with 39%, and then smart meters at 25%.
It's interesting, once again, a
Yeah,
broad spectrum of answers or systems that are out there and the way those have been implemented. So
yeah, it's great to see that smart meters. So it looks like almost a quarter of our audience has smart meters in place, which is fantastic. And a vast majority have some kind of building management system in there. I would have thought maybe smart thermostats would have been higher, but I mean that's great to see. All right, shall
and
we
the
jump
thing
back
is,
in?
and maybe it was you could only, you were debating on, selecting one versus the other, but we'll
Yeah,
talk about all of those here coming up shortly.
yep. So I'll speed up the cadence a little bit. I think we've introduced a lot of the core concepts, and I want to have a lot of time for HVAC health, which I think is super valuable to this audience. So John, we'll jump to that soon here. Um, Really quick, we all know sustainability is at the forefront of finance and investment today. It's being talked about, and it is an important aspect for you to be prepared for if you're not already. I'm not going to spend a lot of time on this slide, but my main takeaway is um, a lot of the concepts we've introduced are natural elimination of waste, of energy waste, right? Particularly around HVAC and refrigeration and even energy monitoring, right? We talked about limiting strain on the power grid. All of these things are reducing your carbon footprint. But more importantly, they're very low cost ways to take a huge chunk out of your carbon balance, right? So if you're an enterprise that is thinking about becoming net zero or paying for renewable energy credits or paying to offset your footprint in any way, all this energy waste from your HVAC assets and so on is increasing the cost burden you're going to have to face as you approach, as you go after net zero. So what we advise to people is before you go invest in, buying renewable energy through special contracts or installing on-site power generation, which can be very, very expensive. The first thing you should be doing is eliminating waste. It is the lowest cost way to take a massive chunk of your of carbon out of your carbon balance. And so the last thing I'll say is many of you may be already kind of taking energy bills, working with your UBM, utility bill management platform, and saying, okay, let me take this energy data, we'll total it up, and we'll say what in the U.S. is the average ton of CO2 per unit of energy consumed, and you may be multiplying by one number, and that may be more than fine for what you're trying to achieve with your sustainability goals. There is an opportunity, and I'm thrilled that a lot of you have metering in place as far as power generation, because you're already seeing the benefits of having a much more granular view into energy consumption. You're seeing it by the hour, maybe by the minute, and so what you want when you're looking for a building management system or looking to enhance your existing building management system is, is there a platform where I can say, what is the grid mix at my location in California versus my location in Idaho versus Maryland versus Florida, right? Those may be very different grid mixes. We may have some locations where they're running on 60% coal. In the case of Texas, they may be 60, 70% wind on the average day. So if you're just slapping one carbon conversion factor across your whole, if you have facilities that span the country, that you may be actually very much overestimating your carbon footprint or maybe underestimating it. So what you want is a system that can line up your energy usage with real-time knowledge about the grid mix. And many of these smart building providers are starting to do that today, which is really exciting. They actually have integrations with utilities, and in real time, they're pulling in information about what's the grid mix, what is the carbon density of the grid at this moment, and lining that up with your energy consumption to give you a highly accurate depiction of your carbon footprint. Let me go to the next slide here. All right, John, take it away. I think you're on mute.
Alrighty, so let's talk about maintenance. I don't think so. Can you hear me?
It's a little lag, but yes, I can hear you.
I'm not on mute. Can you hear me?
Yes, we hear you.
Okay, I'm sorry. Let me know if oh, okay, gotcha. Maybe it was on Jamie's side. So there's three types of maintenance out there, you know, reactive, preventative, and predictive. You know, some companies, which basically reactive is, you know, you just run a piece of equipment until it breaks, and then at that point you're looking to do maintenance on it to try to get back in operational condition. You know, some companies prefer that type of a method. It has a lower, you know, upfront cost. You're not spending, you know, money on time and personnel to, you know, to keep things, to stay on top of things per se. But it comes at a disadvantage that, you know, equipment, you know, once it breaks, then you're kind of in an emergency situation. You know, truck rolls begin, and, you know, potentially things aren't being taken care of the first time because they're in a rush just to get it back online. And so now you're set up for additional truck rolls. So even though it might be cheaper up front, in the long term, you know, you can potentially spend a lot more, you know, reducing the life of equipment, maybe perhaps prematurely, or, you know, once again at the cost of the comfort for employees and customers. Preventative is like a step up from that, where you're out there on a, you know, proactive basis, going out there and, you know, changing filters, you know, testing, you know, levels of refrigerant in the units, you know, replacing belts if need be. And this is a pretty good strategy. I mean, it does have more cost associated with it, but you're hopefully going to catch, you know, minor issues before they've happened, and you're also going to be able to maintain that in the future. But even a step up from that is predictive, where we're actually using condition monitoring tools and techniques to kind of keep track of where an equipment is at, how it's operating now, and actually be able to decide, hey, it looks like that unit is going to go out. You know, let's go ahead and do something about it now, while we can choose when it's going to be replaced or be repaired instead of being forced to shut down. Go to the next one. And, you know, various studies have said, hey, you know, predictive maintenance, you know, can save as much as 8 to 12% over preventive maintenance. Predictive can also do as high as like 40% over just reactive maintenance. When you consider that a truck roll can, on an average, is costing about $450 to go out and do a repair, I mean, that adds up to quite a bit. Last year alone, we observed over 32,000 HVAC units that were malfunctioning in one way or another. So start thinking about potentially how many truck rolls are being initiated to take care of those units. So wouldn't it be nice to be able to really prioritize of all the units? You know, obviously this is a large portfolio, but even for you as a customer, to be able to prioritize those. So.
Yeah, so I mean, I think this is clear by now. I'll go really quickly through here, but you know, when you install a BMS or when you enhance your BMS to do some of the things we've been discussing today, you're reducing truck rolls, you're avoiding supply chain delays. So for example, if you're doing reactive maintenance, you're going to have to be hustling to fix that HVAC unit. And that means you're going to have to be paying more likely to get parts. We all know how difficult that is today. So you want to be more predictive so that you can have the parts on hand when things break. Scheduling the least disruptive time to take care of assets, and reducing costs and risk associated with these installs. Really the takeaway is you want to be prepared, and data helps you be prepared.
So let me show an example of the kind of information you're going to get from a proactively monitoring of HVAC units through a smart automation system. First, you're able to actually identify which units have problems. You're monitoring them. And then from there, we're able to make priorities based on what we know about them. In this particular graph, the top units represent units that aren't drawing power. They're also not showing that they're heating or cooling properly. So those are pretty much look like they're dead in the water. Hey, let's go out and get those repaired right off the bat. The next unit's a little bit below. They're not heating and cooling, but we don't have as much information on them. We just know that the duct temperature monitor shows that the supply air is not conditioned properly or adequately in order to control the area. So for those, maybe it's not an instantaneous call like the ones that we know are dead that aren't reaching temperature and aren't drawing power, but we probably need to add them pretty high on the list to be looked at within the next 72 hours, especially if it looks to be a recurring error that that has happened over a couple of days time. And then another level would be, okay, the unit is not reaching, or the zone at least is not reaching a recommended temperature, but the supply air coming out of the unit does show that it's actually supplying the proper amount of air, or the right conditioned air. That could be as simple as, somebody has left a door open or a window open that shouldn't be, but it could also mean that there's a unit unsized, is undersized, or in brand new installations where we've added the system, now all of a sudden they figure out, hey, the zone sensor is not even in the right place. That thing never worked right. And I cannot tell you how many times that has happened, that by having this information. And then at the lowest level, all we know perhaps is the zone is not reaching temperature. So what I want you to imagine is, let's say you have a portfolio of units you're in charge of. There's 50 of them. And let's say all you have is a smart thermostat, but you don't have any additional feedback other than the zone. You don't know what the supply air is doing. You don't have any current usage from a submeter. In your mind, those 50 could be based on number 4, which is, basically all of them are priority. You don't have any way to distinguish between them. So if you add additional sensing capability to your system, like supply air temperature, current usage, now you're able to take those 50 with that additional information and actually prioritize which ones you want to work on. You can go to the next one. And this is, just an example. Once again, if you've got an enterprise, so you're potentially managing tens, hundreds, or thousands of HVAC units, being able to have a snapshot and a view of all of them collectively, where I can say, okay, of these various sites here, I'm going to prioritize them based on which ones are the farthest away from set points. And then that would give me a list, or those the ones that we need to look at. Or if you go on to the next slide, we could actually dive in a little bit deeper to a specific location. So in this location, I'm at a single site here in Katy, Texas. There's 24 units. And of those, I have 4 that are starting to show performance issues. If you look at that top unit, you'll see that, basically it has had 18 cooling issues. Of those, 16, it was not reaching set point, and 2, we didn't even register that the units were putting out, cold air, as an example. So the temperature on that unit is almost 6 degrees out of what the set point is. So obviously that one needs to be, worked on right away. Now, the thing is, when you start looking at some of these other units, if you notice, like that AC22, it has had 2 cooling issues. But if you notice, that also corresponds to the other unit that's not working having not cooled at all. It could be as simple as the AC18 is not maintaining temperature in its area, and that is actually causing the other units that are listed here to actually take on extra work to have to cool their area that's being affected by another. So once again, by being able to prioritize, you might figure out that, hey, the real problem is at AC18, and these other ones, those problems are going to disappear once we get that. So, once again, the more information you have about sites, I'm sorry, just one quick, if you go back to that one last slide, Jamie, one more, sorry. If you, think about this. If you have multiple sites and different people calling up to say, hey, I've got problems, you may have somebody that actually, because you have duct sensors, that it's not reaching, it is reaching temperature, but it might be an external factor. If that person calls all the time, you might think that that is the priority versus somebody that has a real problem and maybe only called you once. So by having data, you're able to kind of take out some of the human factor and actually understand what's really going on, and then you can have better communications with those at the potentially the store level or facility level.
Yeah, absolutely. And the last thing I'll add is just that real-time data, right? You're pulling out your phone, you're going to the site, and you're seeing exactly what's going on in real time. You don't need to roll a truck or even call the site back to ask more questions. You have all the answers in your pocket. All right, your poll.
Perfect. We've come to our final poll question. What strategy are you using for ongoing asset maintenance? Select one of the following. You have about 20 to 30 seconds to respond. Okay, the results are in. So it looks like on a schedule for example, every 12 months is at 63%, the far and away majority. After that is run to fail with 26%, and then predictive failure with data and reporting at 11%.
Yep.
That's great. Yeah, I thought run to fail would be like 95%. So this is great. we have a really good audience here. This is awesome. All right, let's jump back in. I know we're short on time here. Yeah, I just want to talk about results. I'll try this in 60 seconds. So at this particular customer's franchise, which is a Burger King franchise, we came in and we only swapped their thermostats out with GridPoint thermostats, and we installed our GridPoint intelligent controller. So it was really just coming into the facility, swapping out the existing thermostats with GridPoints, mounting a touchscreen controller in the manager's office, and providing this customer with automated energy management software and also energy advisory. So they actually had a dedicated GridPoint member, walking them through everything, building them reports, and showing them insights. And just with these small modifications to HVAC, they've achieved $4,000 in savings per location per year, which amounts to a 21.6% energy reduction in energy usage. So again, simple things like getting control over your set points, bringing all your thermostats into one platform. You guys would be amazed at what difference this can make from a savings potential. And this particular customer, the solution was delivered for a monthly fee, and their savings each month were greater than the fee they were paying to GridPoint. So they're actually net saving money after the cost of GridPoint. And so when you're looking around at different solutions for your facilities, you want to explore both upfront capital options if that's best for your organization, or actually a monthly fee where it's more of a service subscription, which is typically what GridPoint does. But when you're looking around, you want to talk to providers that have both those options available to you if that's interesting to you. All right, and now we're at the questions section.
Yes, absolutely. Thank you both so much for this presentation, and thank you to our attendees for sending in questions. We'll now have the Q&A to address the questions that you have sent in, and please continue to submit any questions that you may have. Okay, so to start out, what sensors are needed for HVAC health?
So primarily, the most cost-effective is supply air temperature. I mean, that is the most basic. It lets us know if a unit is putting out hot or cold air per the command of the thermostat. It's a very simple install that's wired directly up to the thermostat, which collects that information. And really, that can tell you a lot. I mean, as you go beyond that, then we can get into adding a CT, so we can look at the energy usage from a unit. From that, we can do analysis as far as like cycle time, run time. Hey, maybe a unit doesn't appear to be working. Well, it's also not drawing near as much current. Maybe a bad contactor not pulling in the compressor. I mean, there's just various things that can be done, but that's the most basic, is just the temperature. You know, a thermostat is a control device most generally, not your standard one doesn't have inputs. It's not like the device is given specific feedback, but the temperature can tell a lot. Is it working or not?
Perfect. Great. So another question we have here is, how can I put my thermostat on a schedule?
Yeah, so go up, walk up to that thing if it's not, you know, kind of a smart connected thermostat, and you know, you should be able to set pretty basic scheduling as far as time of day. You want to make sure your fans are on auto. You don't want things on hold. Typically, the hold function is going to have that thing running 24 hours a day, and we see that all the time. You'd be surprised how many facilities have their system set to hold, where they're cooling all day long, even when no one's in the facility. So, you know, and if you do have a building management system, try to learn more about how you can set kind of global set points and schedules for your facilities. You want to create some rigor around how you set those up and some boundaries. And then also you want to be instilling overrides if your technology enables it. And overrides really allow you to set boundaries around, if I'm a manager at a facility and I go walk up to a thermostat on the wall and I try to crank up the AC because I'm hot, how much can I change the temperature and how long will that stay in place before automatically resorting back to the enterprise-wide set points and schedules that you've established for your facilities. So yeah, if there's any takeaway from this, go look at your thermostats and see those schedules and try to you know, definitely do an audit, because we see we see crazy stuff out there as far as you know, many thermostats have been set to hold or just very aggressive set points when no one's actually in the zone.
Perfect. Perfect. So another question we have here is building automation worth it if our building is small?
Yeah, that's a great question, and absolutely it is. You know, with just, you know, a couple of RTU units, one of these systems that is automatically maintaining the temperature can definitely justify paying for the system and giving energy. So they're not just for big systems. I mean, once again, I mean, you know, you think of a smart building, I don't know, what comes to mind is like, oh, you know, this multi-story facility, and really that is not true. I mean, small buildings, and once again, that's part of the market that like we serve, because that's been overlooked forever by the, you know, the big name building automation folks. And it, you know, took a smaller companies to come in and say, hey, all of these buildings, there's a bunch of them, hundreds of thousands of them that nobody's been doing anything about. And that's where we specialize in.
Perfect. So we have one other question. How does GridPoint interface with a Distech Controls BAS system?
So I'm not sure on the particular manufacturer, but GridPoint system, we are able to do custom integrations with other platforms. That can be through an API where we're ingesting signals from another system and also talking to that other system, you know, just through an API integration where that's all kind of cloud connected. We've also connected to other systems on site through physical connections. We can have third-party sensors plugging into our input modules, reporting up that data into our cloud platform. We can have our sensors plugging into your hardware, rolling up to your cloud platform. And so we actually do see many clients having hybrid systems where they're using GridPoint for certain aspects of their facility, such as HVAC and refrigeration. And that's kind of integrated either through a cloud connection or an on-site connection to maybe a separate lighting system or other systems that you may already have in place. So yeah, I hope that answers the question. I do appreciate the question too.
Perfect. And I believe we have time for one final question. My refrigerator is 20 years old. Can I still use a VMS?
Yeah, I mean, it depends on the level. You know, whether you're talking about, you know, a system that's 20 years old, probably, you know, the best thing that could be done is to just monitor on a regular basis through like one of these building automation sensors, you know, what is the temperature of that unit? And let's log that and keep track of it. Let's, you know, pay particular, and then start understanding a trend of how it's operating, to try to retrofit the controls on something that's old. I'm not sure if the payback would ultimately be there, but at least to monitor it on a regular basis so you can be alarmed when the unit does have a problem. I mean, that could potentially be the best, most cost-effective and simple way to help protect the product that's in there.
Awesome. Well, it looks like we're out of time. Thank you again, Jamie and John, for today's discussion, and to GridPoint for sponsoring this webinar. And of course, thank you to our audience for attending today. A recording
Thanks so
from
much.
today. Yeah. A recording from today's session will be made available on our magazine's website, facilityexecutive.com, and at gridpoint.com. Thank you, everyone, and have a great afternoon.